Hi everyone, I hope you are doing good out there. And today we're going to talk about bias theorem. It has been a complex video for me when I was in my high school, and I was being tired of seeing examples of taking out balls from the bag, different color of balls, tossing coins, and these are the not events we see in our daily life, and it is very hard to relate on those examples. So I thought maybe we can do better on that, and you can also see this complex formula with a lot of equations over there, conditional probability and this whole thing, right? And it was very hard to remember. I could understand it for a week or something. I'll pass my exam and then move forward. And after 1 or 2 years, bush. I don't even remember it. What was it? But but this time we're gonna come up with a better way of understanding it, very intuitive and visual way of understanding, and so that we can understand it for the last time. And probably I hope that you don't need to watch any video after this on this topic. So let's get started. So let's start with the example. And the example is you are in a movie theater, and it's quite dark. And there's a person in front of you who left his receipt some over there. And as you were walking out, you wanted to return that receipt to that person because you are a very nice, generous guy. And the only thing you can see in that dark was the long hair which was in front of you, and you didn't recognize it as a man or woman, something like this, right? So if I ask you, what is with your general knowledge, what is the probability that finding that person is a man or woman, right? Given that he or she has long hairs, and if you use general data and general common sense, right? You would probably say that it might be a woman because most of the women has long hairs, and I will say you are absolutely right about it. But as we know certain new information about this situation, we will see that these situations, this might not be the case, or maybe it is that same case, right? So let's continue that. So the problem says that, as I told you, 80% likelihood that there are women with the long hairs, 20% that men do. Funny part was that movie was Oppenheimer, and the majority of the people came was men. It was like 90/10 ratio, right? 90 will be like, think like if there is 100 people, 90 of them will be men and 10 of the women. And while the most of the rest of the women of that town went to see Barbie, so there was not much of women in the crowd. So what is likely to be, it is a man or woman given this fact that they have long hair, right? So how you're going to proceed, it is the problem of bias theorem, but you don't have to think like that. You don't have to bring the formula and try to take out variables from here and input it in something like this. But we're going to see a visual picture of it, right? So what we're going to do is we're going to assume that situation that whole people, like imagine there is 100 people, right? That will make us, sometime you can take 1,000, sometime you can take 100, basis on your numbers. I'm picking 100 over the thing that there is 100 people on the theater, and this red block over here represents the men, because I'd say it is 90%, and 10% was the females over there, right? So you can see, and then there was extra information that 80% of women have longer hair. So I can fill this area with 80% with some color and say this is the woman with long hairs. And then we can fill this with 20% and say that the men with long hairs, right? So it will look something like this. 80%, 20%, I think. This is all the information we have got from this thing. Now it becomes very simple. Now if I have to ask you, what is the probability of women with long hair? So these yellow part represent women with long hairs, right? So how we find the probability? Basically, whatever the input you're trying to find. So this portion divided by this yellow whole thing, right? Basically, this is the all the long hair, people with all the long hairs. That is your total sample space, right? As you can see in the picture. But a lot more time when you don't have this image of square or something like this, people tend to have total sample like misrepresent total sample space with this whole thing. They consider this whole 100 people as their sample space. But in this case, it's a long hair. Given the fact that it's long hair, you already know this fact. So the total sample space is long hair. So input is basically this yellow portion divided by this whole sample space. This yellow plus this yellow. Women with long hairs plus men with long hairs. That will be your denominator, and the numerator will be this part, right? And if you do the calculation, you will get it. So how we can find? So first of all, you need to find this. What are the number for this yellow part, right? So imagine there are 100 people, 90% of 100 will be 90, and then that then the 20% of the 90 will be, I think, around 18 or something. Yeah. So this will become, this LO part basically means that 18 people are men with long hairs. And if you have to calculate this one, 10% of 100 will become 10 only. And then 80% of 10 becomes 8. So 8 girls are there in the whole theater with long hairs, right? So I have to find the probability it is a woman given that long hair. So 8 divided by 18 plus 8, right? And that will give you the answer, probability. And same you can find it for men, basically dividing this portion with all over yellow, right? And if you find it hard to see the numbers, right, don't worry, I'll show you how the calculation goes. So just for general purpose, I wrote the formula, but we are not that much using the formula over here that much. But you can see probability of women, this part is the woman, which I bring over here, divide by the total sample space, this is, and we're going to find this part. So this area, if you represent, so this part, probability of women. So this is basically this blue rectangle is probability 1, basically 10 upon 100. You can write over here, and probability that is long with 1, basically 80%, right? So this 80% multiplied by 10%, that will basically. So this is the yellow part, obviously, right? So over here, that will be the value over here, and we can churn some number over here, and it says 80% of 10, and basically what I just told, divided by the sum, like both of them. And when you actually do the sum, you find that becomes 8, and then 8 plus 18, and that becomes probability. Probability that it was woman is 30.8. Initially, we like understood 80% of women, right? So that would be the 80% that it will be a woman, but you can see the number, it is quite diminishing. And we'll see with men as well. So to find the probability it was a man, given that it was a long hair, probably this portion divided by the whole sample space. This is the formula if you need that, but we don't really need the formula. It's so easy to see from here. Bring this block over here, divide that by total sample space, and again churn some number. Obviously these numbers will appear again. So 8 plus 18 divided by 18, that becomes 69.2. So you can see in this example, right, it's like almost twice, I would say, more than twice the probability, right, it will be a man, right? In general world, if you see a long hair somebody, you probably think it's a woman. But in this scenario, given this new information about this movie was Oppenheimer or something like this, and now you can see it is more than double. So what a world we are. So this is the way, the Bayesian thinking we call it. And we can see the use of Bayes theorem over here. This is termed into kind of formula like this. But somehow we don't need formula when we can represent the problem in this way. And you can solve other problems like this. You don't has to be like this particular example. So probably you're going to see some intermediate problems. Then in the last, you're going to see some hard problems solving with this method only. So let's continue with that. So another problem is vehicle accident probability problem. This problem is basically in a city. We have 60% of vehicles are car, 40% of motorcycle, which kind of true. Which makes sense. Probability of car being involved in accident is 10% because it is always covered and all and everything. Probability of motorcycle involved is in 5%. That's very amazing. That's a stats we have over here. And if an accident occurs, what is the probability it is involved in a car? So we have to find the probability of like we already know accident is going to occur. Given that the accident has occurred, what is the probability it is done by car, right? So this is the information. You're going to use the same method. We're going to make a square. So these are 50-40%, right? We can think in the city we have 100 of vehicles, right? And 60% is car. So you can draw a box like this. This represents the car. 60%, 40%. This represents a motorcycle. And then it later told on 10% of accident was occurred in the car section. So this area defines the accident on the car side. And this defines the area on the this thing on this side. And one point to be noted that you can already see the solution, right? This area is small and this area is quite big. So probably the higher probability on the car side. Car has most of the problem. And I even forgot to tell you that was in the previous example as well. If I told you the theater problem, right? over there as well, if you look, the size was quite bigger on this side, this area, which is basically representing the, what do we call, boys. This is bigger boy size, right? You can see over here, boys has a bigger area over here, right? More people has with long hairs, right? So you don't have to actually go and calculate things. From just figure, you can tell which has the highest probability. So that solves it. Same in this case. This are 40% are motorcycle, this are 60% are car. And even that 10% are the accident which was occurred by car. So these are basically accident occur. Yellow lines are basically all the accident occur. 10% was over here that looked over here is by car and this thing. So if I have to find a probability, this will be the probability of it was a car and the accident has occurred, will be this portion divided by total sample space. Not this whole thing, just the number which has accident occurred. So these yellow ones are the accidents, right? So we can do that. We can write formula just for you to solve. So basically probability of car, car is basically this whole rectangle with blue thing. And then that is 60%, 60 upon 100 multiply with 10 upon 100, like 60% of then 10% of that 60, right? That will come over here and divided by the whole thing, basically the sum of these yellow parts. That you can see, some equation you can find. So we'll bring this value as a numerator, divide by the total sample space, which is this all area, and we need to find the sum of these two, right? So you can see 10% of 60% of 100, whatever the number comes, then find the 10% of it that will represent the accident done by car, divided by total sum. And you can see over here, this we have already find it over here, so we don't have to redo, just we have to find for this one. So 40% of that, if you're considering, let's say consider that there was 100 vehicle all over, the 40% motorcycle, yani 40 were the motorcycle, 5% of 40, whatever the value will be, I think it will be 2, I guess. So 6 plus 2, 8. So 75% of accident probability that it was a car is actually true. You can see over here, right? The area is quite bigger as compared to this one, so it makes sense. And same we can do with motorcycles. Same again, the formulas. This will be the same, 6 plus 2, and then now we have to divide with 2 because the probability it was 2 over here, right? So that we can do over here. And that gives you a solution. I don't think it is very hard, and you have to remember this formula even. Just by seeing this diagram, you can get the idea and you can probably solve it. So I hope you have understood the method, and we don't need formula for that. Basically, we can derive formula on the spot. The trick is to represent your ratios in form of squares and then defining the problem, whatever the information given, make the space, and probably like 90% you will understand which has the higher probability. Just to churn down number, you have to do some calculation which basically require percentage or something, and that way you can solve a Bayesian problem, right? Without remembering the jotting down or without memorizing the formula for it, right? So I hope you have understood it. And this is a very good problem actually, because it has a lot of application if you just go in the future, like if you're trying to be engineer or something. They have a lot of application where this Bayes theorem has been done. As an AI engineer, I have used multiple times. Like basically, I can give you an example. Like in your phone, if you see those spam classifier, there's a high chance that that was built with Bayes theorem. So you can definitely use Bayes theorem to classify things, right? So there is a classification algorithm made out of a Bayes theorem called naive Bayes, right? And so those are these algorithms which are very useful in our real world, and the foundations are like basically Bayes theorem. So I hope that motivates you to learn this theorem. And there are so many multiple use cases. The one which I have used, I have told you, and I definitely feel that I feel that you don't need another video to watch on Bayes theorem.